Ferrari has recently filed a patent for a hybrid car with an inverted internal combustion engine powered by hydrogen. Although it may seem far-fetched, and yes, you heard right, an inverted engine, let me tell you what it is and then you can draw your own conclusions. We're getting started. At first glance, it may seem puzzling that Ferrari would go for an upside-down engine design, especially when it comes to a hybrid system that uses hydrogen as fuel. However, the key behind this choice lies in the proposed layout of the fuel tanks. Imagine 4 tanks, each capable of storing more than 10,000 psi of hydrogen gas. If you want to know more about hydrogen engines, we already made a video where we talked about them in depth. I leave it in the description. Let's continue with the video. 2 of these tanks, spherical in shape, would be strategically placed on either side of the engine, while the other 2, cylindrical, would be located on top of the engine, with one of them extending forward, just in front of the rear wheels. This unique arrangement presents a design challenge, but Ferrari, in its patent, is not limited exclusively to an inline 6-cylinder engine, although that is its preference. Most interestingly, the proposed vehicle would be a hybrid, with an electric motor driving the front wheels. Considering that it would be inverted, the question arises as to why there are no reverse engines, so let's talk a little about this, and if you have other ideas, comment them down here. Well, and the reason is simpler than we think, and that is gravity, but wait, don't get ahead of yourself. Unlike fuel injection, which is not significantly affected by engine position, lubrication is a major challenge in this type of configuration. In a conventional engine with wet sump lubrication, gravity helps drain the oil into the crankcase and oil pump, making it easier to circulate. Also, since the crankshaft is generally located at the bottom of the engine, the lubrication path is relatively short. Ferrari's proposed solution for its inverted inline 6-cylinder engine involves a pressurized dry sump lubrication system. This system uses 3 pumps, one to pressurize the feed side, located on one side of the block, and 2 for the recovery side, located on the other side of the block. These pumps are connected to the engine through the camshafts, extracting and sending the oil to a recovery tank. Although this configuration resembles a conventional dry sump system, which we'll talk about in a moment to better understand, this still poses challenges, such as the possible leakage of unrecovered oil into the cylinders, which could lead to hydrolock, a mechanically disastrous situation. Ferrari does not provide a full explanation of how it addresses this problem, but seems confident that the recovery pumps are effective enough to prevent it. But then what is the conventional dry sump system? Let's look at some more of this. In essence, in a dry sump system, the oil is stored in a separate auxiliary tank instead of in the sump pan. This prevents the oil pump from running out of oil during intense maneuvering, ensuring stable and solid oil pressure. In addition, by removing oil from the crankcase, wind resistance is reduced, which can increase engine power. This system involves the extraction of a mixture of oil and air from the crankcase through an externally mounted pump. The oil is then directed to an external supply tank, where the air is separated from the oil. From there, an oil pump draws the pressurized oil from the supply tank and sends it back to the engine. This design ensures a constant supply of oil, regardless of the G-forces at play. Continuing with the patent, there are also 2 surprising concepts related to the transmission and turbochargers. First, the transmission is a 7-speed dual-clutch gearbox, which, although inverted, is still fairly conventional. What is unconventional, however, is that the dual-clutch assembly is not coupled to the engine. Instead, the input shaft is connected directly to the crankshaft. Why this peculiar design? Ferrari intends to take advantage of the twin centrifugal superchargers located inside the transmission's dual-clutch drum. According to the patent, this optimal location allows for reduced pressure drops from the outlet to the intercooler. These superchargers would share a common gearbox shaft, driving them up to 100,000 RPM, while the common shaft would rotate up to 10,000 RPM. Even the possibility of connecting an electric motor to these superchargers to generate power, increase boost and even control it is contemplated. But that's not all. The patent also presents an alternative proposal for a turbocharged version with divorced turbines and compressors. In this case, they are not separated by an engine in the middle, but literally split with only an electrical connection linking them. The turbines would have a generator connected, and the power generated would be sent to a battery for storage, then used to drive the compressors connected to a single engine. Yes, it needs to sink in again. The compressors drive a generator which, in turn, supplies electrical power to the motor to start the compressors. Do you think this might see the light of day? Comment below.